All right, I think I'll give a quick overview here of the dyno. Basically, spent a bunch of time setting this up here. I'll kind of switch camera views here in a second. Basically, I've got it all set up here. Two Nissan Leaf motors, so I can actually run it. One in regen, one is the drive motor, with two of our Axiom motor controllers. So this way we can sort out all the parameters, get it tuned really well, spend a bunch of time setting up the resolver, all kinds of stuff. Have it running pretty good. Today I've upped the voltage to what should be about 350 volts fully charged. We're gonna do a run with that here in a minute. So basically this is the setup here. It's not perfect. I'll be adding things, changing the cooling system eventually. I have quite a bit of stuff to do to it. I have an electric vehicle heat pump, three-phase motor. That's a three-phase motor attached to a compressor, a scroll compressor, that I'll be building a little cheap controller for. Well, not too cheap because it'll be high voltage, but nonetheless it'll work off of the main battery pack voltage, and it'll let me do what I want to do to move the heat around, so I can heat the interior, cool the interior, cool the motors, cool the controllers, all kinds of stuff. So there'll be some pretty neat things that happens with that. But for now I just got a Radiator, which is actually a Honda Accord heater core, and then just a little fan on it. I found a better fan which I have running on the other side. I have a couple little things on order for that as well. I have some inline filler neck adapters inside there. I have a power supply that runs my 12 volt stuff. You can see the two Axioms, plexiglass on three sides of this so that there's less risk of a plasma ball getting me somewhere. Try to always wear safety glasses. Got a 100 amp, I think it's a 500 volt DC rated circuit breaker. Couple contactors on switches here that I can shut off. I have one that's for pre-charge, one that's for the second contactor. I have to remember to put a piece of tape on that. Kind of use duct tape as like temporary protection. Let's see, we've done some DC current sensors on each Axiom, so that this DC current sensor here, basically on that main wire coming in, that's actually so that we can make sure that the current flowing in and out of each controller is actually accurate. Down here we have the two Nissan Leaf motors. I've basically built a frame around the two Nissan Leaf motors with the water pumps and cooling system and everything. One is coupled to the other through a little coupler right there. That's something I welded together. It works pretty good as long as there's a load. It's a pretty good setup. So I think we're going to get on to a run here in a minute. Basically, I'll close this off. And we have both of our Axiom setups here. I've basically set up my current to be a max of 600 on each controller at the moment. I think we'll start with that. We'll go back to 600, and then basically we'll get things running here. Just did a quick little adjustment on the DC current sensors. I used my scope and my fairly expensive DC current sensing, or AC DC current sensing probe, and basically calibrated the DC current sensors. So now we've got everything pretty accurate. So we'll get it running. We'll probably bring this up to 10,000. So maybe we'll start with 8. We'll get it running to 8. We'll do a test, and then we'll do a little more even after that. So here's a little bit of a run. 80 kilowatts in right there. So now we'll bring it up a little higher to 10,000. And then we'll do one more test here. Pretty good. I think that'll be it for tonight. Stop this. We can look at the currents, current in, current out. 200 amps, 230 something amps, 240, 30 something amps in, and around 200 amps out. So not too bad. Basically everything's looking pretty good. 700 amps phase current there. We peaked 700 and something amps here. Let's see, general current. We're set to 800, so we can actually do one more test. We had it probably spinning a little fast, so we'll go 9,000, and we can do that one more time. Have a look. The temperature come up to 50, but we'll turn this back on. Let that, so we can see the temperature's already cooled off pretty good. Once I get going with this, I'll increase my coolant capacity here, but everything's looking pretty good. So put the spin it to 9,000. That's pretty good there. So probably stop it. And you can see it's pretty cool to see the temperature cooling off that fast there. We're going to look at the temperature on both input and output. They both hit about, this one hit about 50, maybe 7 degrees, and this one hit, maybe 53. So not too bad for peak versus peak. It looks like, I think that's the middle IGBT that's getting the hottest, kind of as you expect. Looking here into our FOC, we can kind of see the currents. You can see D-axis current stays at 0. We haven't enabled any field weakening or our maximum torque per amp yet. You can see the current here was just over 200 this time. That's regen current, and this current was it peaked just under 250 amps there. So that's not too bad. That's a pretty successful run. Seeing 80 something kilowatts there. That's pretty decent. I think we're going to call it quits for the night.